So, the today's topic is nuclear fission and fusion. And first, we will understand that what is nuclear energy. Okay, so the first topic is nuclear energy. Now, see, we know that inside a nucleus, this is nucleus, right? And these are the orbits of the electrons around the nucleus. And inside the nucleus there are neutrons and there are protons, right? So what happens if we add the masses of neutrons? This is an element X which has an atomic number Z and mass number A. It means there are Z protons inside the nucleus. Okay, and A minus Z is the number of neutrons. Okay, inside the nucleus. Generally what happens, the sum of the mass of all the protons, mp is the mass of one proton and z is the number of protons, so this will give you the total mass of the protons plus mass of all the neutrons. Mass of one neutron is mn and total number of neutrons is A minus Z. Neutron and proton are the constituent of the nucleus. So sum of the separate masses of all the constituents of the nucleus is always greater than the total mass of the nucleus. It means some mass is lost in the formation of nucleus. How can we find the loss in the mass? It is represented by delta M. Okay, and this is given by the sum of individual constituents, that is Z into MP plus A minus Z into Mn, all right, minus mass of the nucleus, right? This is the loss in mass while the formation of a nucleus. So Einstein in 1905 suggested that the mass and energy are interchangeable. Means if the loss in the mass is delta M, then its equivalent energy is given by delta M, that is change in mass, or it is also known as mass defect, into square of the speed of light. So if delta m is in kilogram and c is the speed of light in meters per second, then energy will be in joules, right? And this energy is known as nuclear energy. E is called nuclear energy. All right. Now, what is the energy equivalent to 1 kilogram of mass? See, energy equivalent to energy equivalent to 1 kilogram mass. How can we find the energy equivalent to 1 kilogram mass? Right? How can we find the energy equivalent to 1 kilogram of mass? Means here we will take delta m to be equal to 1 kilogram and c, the speed of light, to be equal to 3 into 10 to the power 8 meters per second. So the energy equivalent will be equal to delta m into c square. So this will be equal to 1 kilogram multiplied by 3 into 10 to the power 8 meters per second whole square, and this will be equal to 9 into 10 to the power 16 joule. Okay. Now we know that if we want to convert it into kilowatt per hour, then we know a relation that 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. So, to convert this 9 into 10 to power 16 joule into kilowatt hour, just divide it by 3.6 into 10 to power 6. So the energy in kilowatt hour can be obtained as 9 into 10 to the, so 9 into 10 to the power 16 divided by 3.6 into 10 to the power 6, and this is equal to, when we will solve it, we will get 2.5 into 10 to the power 10 kilowatt hour, right? So 1 kilogram of mass change is equivalent to 2.5 into 10 to the power 10 kilowatt hour. Okay. Atomic mass unit is the unit to represent the mass of atoms and nucleus, electrons, protons, neutrons, etc. So now we will study about the energy equivalent to mass 1 AMU or simply 1U. See, so energy equivalent to 1 atomic mass unit, right? So 1 atomic mass unit can also be written as simply 1U, okay, or unified unit. So what we will do, first we will convert this 1 atomic mass unit into kilogram, and then we will convert it into joules, and then in mega electron volt, right? So first, according to definition, 1 atomic mass unit or simply 1U is equal to 1 by 12 into mass of one atom of carbon 12. All right. So how can we find the mass of one atom of carbon atom? So this is 1 by 12 multiplied by 12 kg divided by the Avogadro number 6.02 into 10 to the power 26 per kilogram mole, per kilogram mole, right? And when we will solve it, then we will get 1 atomic mass unit is equivalent to 1.66 into 10 to the power minus 27 kilogram. And as we studied earlier, that 1 kilogram is equivalent to 9 into 10 to power 16 joule. So to convert this energy into joule, see, the energy equivalent to 1 atomic mass unit will be equal to, how can we convert 1.66 into 10 to the power minus 27 multiplied by the square of the speed of light, that is 3 into 10 to the power 8 whole square joule. And this will be equal to, if we solve it, this is 1.49 into 10 to the power minus 10 joule. There is another unit of energy which is written in terms of mega electron volts, right? And 1 mega electron volt is equal to 1.6 into 10 to the power minus 13 joule. So to convert this energy 1.41 into 10 to the power minus 10 joule into 1 mega electron volt, we will simply divide it by 1.6 into 10 to power minus 13. So energy equivalent to 1 atomic mass unit is equal to 1.49 into 10 to the power minus 10 divided by 1.6 into 10 to the power minus 13 mega electron volts. So this is equal to nearly 931 mega electron volt. So we get the result that 1 atomic mass unit is equal to 931 mega electron volts, right? This is the result that may come in your exams and how to write it. Okay. Now we can express the mass of electron, proton and neutron in terms of atomic mass unit. So mass of electron is 0.00055 unified unit or atomic mass unit. Mass of proton is 1.00727 atomic mass unit, and mass of neutron is equal to 1.00865 atomic mass unit. So we see here that mass of neutron is little bit larger than the mass of proton. Our next topic will be nuclear fission, which will be covered in the next video.